It's Wednesday, June 11th, 2025, and severe weather is expected across the United States today with a couple areas of increased concern. One up here in the Mountain West associated with a marginal risk, and then one up here near northern Nebraska and Iowa. But our biggest area of concern down here is going to be a small, slight risk corridor centered along San Antonio all the way up to Houston. This is going to be mostly a wind threat with a slight 15% wind threat in our slight risk area, as well as a marginal 5% wind risk in all of our marginal areas today. And then our hail risk is going to be quite small with a marginal 5% risk in all of our marginal areas today as well. And then we have a small, more conditional, and it kind of weighs on a lot of things, a marginal 2% tornado risk down in our slight risk area from San Antonio all the way up to Houston. Here's our simulated reflectivity, and down here in southeastern Texas, we can see some of our morning convection moving northeastward across the state, and we can see that as the sun comes up, it's expected to reorganize a little bit, and this is going to bring that threat for mostly wind and hail. We see mostly linear / scattered mode, so definitely more messy, and that's going to be fueled by a low back here. And then moving further, we actually notice that it kind of creates an outflow boundary that's going to push out, and it's going to situate itself halfway between San Antonio and Fort Stockton. That could be an area that could kind of have increased weather ingredients later on in the day for our second round of storms for this area. And then as this moves off and sort of actually reorganizes again as it pushes into Louisiana in midday to early afternoon, we start to see we get some scattered convection back here along our low and our weak dry line, as well as a stationary boundary situated up here. And we can see that we actually do not get any really organized convection until later on in the night hours. So let's say around 11 p.m. in this area around San Antonio, we can see a cluster of storms fire up here. And another thing to look for is an outflow boundary left by this system along this line, which could kind of increase that tornado threat around San Antonio, as well as that hail threat. But mostly these storms are not going to really have the chance to organize much, because the deep layer shear is going to kind of be limited, and actually these storms are expected to turn into a mesoscale convective system as we go further into Thursday morning, and they will bring that mostly wind and hail threat, but we can see that our shear vectors are going to be more perpendicular to our line, possibly enhancing little pockets of spin-up tornadoes for this region. Here's a weather sounding from Houston for our morning cluster storms, and we can see that the environment is not going to be super primed for tornadoes, but mostly severe winds and possibly some hail. Our photograph does have some curving, but it doesn't really extend out and elongate, indicating that our bulk shear is going to be lower, and also it's going to have a harder time blowing off the precipitation from these storms, kind of contaminating that inflow area. Moving on to our analysis box, we see that our low-level shear is definitely going to be on the lower side, although it is approaching that 20-knot threshold, which is considered the start of decent low-level shear. We see that our low-level spin in the atmosphere, or SRH, is going to be low, and then we see that our bulk shear is going to be low. We would like to see closer to 40 knots, but we're seeing less than half of that, so these storms are really going to struggle to stay organized. Another thing we see is that our lowest cloud level is going to be quite low to the ground, which is helping to make that tornado threat non-zero and sort of hindering that wind threat. But the more mature the mesoscale convective system is, the less the lowest cloud level tends to matter. We see some veering in our winds, which could help spin some updrafts. But something to notice is that our thermodynamics are painting definitely a more stable environment, with it being pretty saturated most of the way up with a little bit of drier but not loads. We see that our lapse rates are definitely above the 6 Celsius per kilometer threshold, but they're also fairly low as well. However, to wrap things up, moving over to our CAPE, we see that we have over 3,000 joules per kilogram in the mixed layer and at the surface, as well as our 3 CAPE. It's going to be quite high at over 181, so that's going to help with the tornado threat today. But our precipitable water is 1.98 inches, and then couple that with our storms having trouble blowing away their precipitation could kind of make the inflow a little more dicey today. So this is definitely painting the picture of a more wind-driven threat with that threat for a couple of QoCS spin-up tornadoes along that line, as well as storms that could produce large hail. Here is our sounding for our second round of storms out closer to San Antonio, and immediately we can notice that this environment is more favorable out there for tornadoes. But one thing to point out is that this sounding is taken near a much earlier time. So if storms initiate later, after the low level jet has kind of waned from that sunset, storms will definitely have a less lackluster environment to kind of take advantage of. But if storms do fire closer to sunset, they can take advantage of more helicity, over 100 surface helicity, better low-level shear, 40 knots of bulk shear, which is what we would like to see. Some varying in the winds that's going to help spin those updrafts. Pretty solid moisture. However, we do see some capping building in. However, our lapse rates are going to be pretty good as well as our low-level lapse rates, and then our precipitable water is going to be quite high along with our downdraft cape, which could also bolster that wind threat in these storms. But this is all assuming that storms fire earlier, but model guidance is trending towards that is not likely to happen. So the only thing that could happen if storms fire later is that our lowest cloud level will be a little bit lower because our temperature will start to decrease. But that capping inversion could also increase, so it's definitely more of a conditional nocturnal threat.